Welcome back. The objectives of this video are to do some samples of binomial expansions using the binomial theorem and Pascal's triangle. You may want to have Pascal's triangle handy for you as we do this video. So our first example here, well, before we get to the first example, let's take a look at the expanding a binomial expression. So we've got a couple patterns here. They essentially say the same thing. If we have x plus b raised to the n, we'll start with our coefficient. Will be n choose 0 and n choose 1 and n choose 2, or you can steal that from Pascal's triangle and so forth to the number of terms that you have. What we will have here, if we're raised to the nth power, we'll have one more term than that exponent. So if we're raised to the 4th power, we'll have 5 terms, etc. Our x coefficients are the x's. Those degrees will count down. So we'll start with n. So if we have x plus b to the 5th, we'll start with x to the 5th, then we'll count down x to the 4th, x to the 3rd, x to the 2nd, x to the 1st. And for the b term, we'll count up. We'll start at 0. So b to the 0, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th, etc. And of course, b to the 0 is 1. So that's kind of what's highlighted in here in samples 1 and 2. And as we go through this, this will make a little bit more sense. So we want to expand x minus 2 to the 3rd power. We don't want to FOIL it all out. So I usually do the coefficients last. So I start with my x's, and that's going to start x to the 3rd, and x to the 2nd, x to the 1st, and then I'll put in x to the 0. And then our 2's or our negative 2's, so this is a negative 1, so we're going to have alternating signs. But if we use our laws of exponents, that'll take care of that. So this is going to be time negative 2 to the 0 and negative 2 to the 1st, because now we're counting up, negative 2 to the 2nd, and negative 2 to the 3rd. So we've taken care of our 2 terms in our binomial, and then we want to take care of our coefficients. Now here we can use Pascal's triangle to do our coefficients. That would be pretty easy. We have a 3rd degree polynomial, so we have 4 terms. We could use 1, 3, 3, and 1. Or we can do, 3 choose 0, the combination of 3 choose 1, 3 choose 2, 3 choose 3. So it's probably just as easy to do our 1, 3, 3, and 1. And now we apply our laws of exponents, and negative 2 to the 0 is 1, so we end up with just x cubed. Negative 2 to the 1st is negative 2. So negative 2 times 3, we get negative 6x squared. And negative 2 to the 2nd is positive 4. 4 times 3 is 12, so we get plus 12x. And then our last term, we get negative 2 cubed is negative 8 times 1, x to the 0 is 1, and we get minus 8. So we've got our alternating signs. We've got our 3rd degree polynomial that has 4 terms, and that is our binomial expansion. And again, certainly on our coefficients here, we could have done the combination. This would be 3 choose 0, which gives us 1. 3 choose 3, combination of 3 choose 1 gives us 3. Combination of 3 choose 2 also gives us 3. And combination of 3 choose 3 gives us 1. Sample 11, a little bit more complicated. We've got a 4th degree polynomial. We're going to do the same process. Again, we can use Pascal's triangle for our coefficients, or we can use our probability notation as well. So we would start by counting down with our two x's. So we'd start with the quantity of 2x to the fourth and 2x cubed, the quantity 2x squared, quantity 2x to the first, and the quantity 2x to the 0, which just is going to be 1. And then for our negative 3's, we're going to count up from 0, so negative 3 to 0 first, the 0 to the first, negative 3 to the second, negative 3 to the third, and negative 3 to the fourth. So now I've done my counting down with my x term, I've done my counting down of exponents with my b term, and now I need my coefficients. And again, if you've got Pascal's triangle memorized, you might know that that particular row goes 1, 4, 6, 4, 1. That would be row, what would that be? Row, because we started 0, that would be row 4. Yep, has 5 terms in it, so that'd be row 4. Or we could look at this as, you know, the combination of 4 choose 0, combination of 4 choose 1, combination of 4 choose 2, 4 choose 3, and 4 choose 4. I didn't do a very good job with that. So our coefficient here is 1, 2x to the fourth, the quantity of 2x to the fourth, so 2 to the fourth is 16. So we have 1 times 16 x to the fourth, and negative 3 to the 0 is 1. So this first term is just going to become 16 x to the fourth. Our second term, we have 2x cubed, so that's going to be 8x cubed. 4 choose 1 is 4, so we have 4 times 8 x cubed, and negative 3 to the first, well, that's times negative 3. So 4 times 8 is 32, times negative 3, and we get a negative 96 x to the third. Combination of 4 choose 2 is 6, so our coefficient is 6 times 4x squared times negative 3 squared is 9. Multiplying all that together, we get a positive 216 x squared. In our next term, for combination of 4 choose 3, that again is 4, and times 2x, and negative 3 cubed is negative 27. And multiplying all that together, we get negative 216 x to the first. And then our final term, our coefficient is 1, 2x to the 0, that is 1, and negative 3 to the fourth is positive 81, and so our last term is 81. And that, now we have expanded 2x minus 3 raised to the fourth. In sample 12, we want to find the coefficient of the term containing x to the fifth when the expression is x plus 3 raised to the seventh expanded. Well, our x's count down, so this is going to be the third term in our binomial expansion, because we're going to go x to the seventh, x to the sixth, x to the fifth. Okay, so this is going to be our third term. If we have our Pascal's triangle memorized, this would be our seventh row, and our seventh row goes 1, 7, 21, 35, 35 again, 21, 7, and 1. So that would be row 7. So we know our coefficient here is 21. Or we could do the combination of 7, choose 2. We can go to our calculator and put that on our calculator, and we'll get 21. Or we can do 7 factorial over 2 factorial times 5 factorial, and simplified. That is 21. So that's not quite, we're not quite done there. That's our first coefficient. That's going to be 21 and x to the 5th. But then we have to remember our 3. 3 to the 0, 3 to the 1, 3 to the 2nd. So our b term here is 3 to the 2nd. So now we have 21 times x to the 5th times 9, and that becomes 189 x to the 5th. So there's our final answer. And in example 13, in the expression 6 over 2, what coefficient does this represent in Pascal's triangle? Well, we had 7 choose 2 when we had something to the 7th, so this would be our 7th row, and 2 was our third term in our binomial expansion, but it represents the second coefficient in Pascal's triangle of row 6. Apparently in Pascal's triangle, we don't count the 1. The 1 is like the 0 coefficient. So our row 6 in Pascal's triangle looks something like this. And this is the 0 term, the first term, the second, the third, the fourth, the fifth, and the 6th term. So of our 7 terms, that's going to be the 0 term. So we would say it is 15, or the second element of the 6th row, if starting at 0, if that's the 0 element, or it's also written as combination of 6 choose 2, which is 6 factorial over 2 factorial times 6 minus 4, or 6 minus 2 is 4 factorial, and that simplifies to 15. So that wraps up our binomial expansion using Pascal's triangle and the binomial expansion, and you'll get some more practice with this when I see you in class.